Hello, everybody. Sorry about the technical issues earlier. I think I got it worked out. Seems to be going okay. All right, so we're going to be talking about this short greenhouse gas activity, just to kind of get a sense of the chemistry of greenhouse gases. It'll also help you practice a little bit with your chemical equations. So before that, just a couple notes on the class. So first off, if you look at the schedule, this week is basically the last scheduled lab, although we are going to have one more. It's just not announced yet. Next week is Group B like usual, and then the week after that is the week before Thanksgiving. So if we do a lab that week, then only half the class does that lab because the Wednesday of Thanksgiving week, there's no school. So instead, we're just going to take that off and have a makeup week. And that's for either group A or B. If you've missed a lab or two and you want to come in and make them up, you can do that on that day. That would be Wednesday, 17th, November 17th. And then we'll have a regular A-B lab on December 1st and December 8th for the last two class. So let me know if you want to come in for that week, because we're still limited on space, so we can't have everybody, but not that many people have makeup labs that they need to do, so it shouldn't really be an issue. Also, if you're doing that, let me know which labs you need to make up. Some of the labs, just because of equipment and stuff like the biodiesel stuff, just can't be made up. So we'll have to work out something else for those. But most of the other labs, especially the earlier ones, you should be able to make up during that week. So if you missed something and you want to come in to make it up, that's the week. All right. The other thing I wanted to mention, I know I spoke in lab a little bit about this to some of you, but there are still missing assignments and particularly missing labs on Blackboard from people that I know were there and did the lab. So if you have stuff still that you have not turned in on Blackboard, get that in right away. I want to get grades caught up before the withdrawal deadline so that you know what your grade is in the class. The weighted average on Blackboard should be a good indication of where you're at right now. And if it's not great, it's probably because of missing stuff. So get that stuff in, particularly the labs. Make sure that if you did a lab, you get it in, because I still want to give you credit for that, even if it's late. Other things, I mean, as they pile up, it may be difficult to get full credit if they're late, and things like quizzes are not accepted late. But let me know if there's any questions, and just turn in whatever you can as soon as you can. All right, thanks. So this week's activity, it's pretty small, and that's because I know you're going to be working on the biodiesel project for the bulk of it. So we're going to look at the chemistry of greenhouse gases, which has to do with how infrared light is emitted by the Earth and then reflected by greenhouse gases. So you're going to look at a couple examples of that, and then think a little bit about what does it mean for something to be a greenhouse gas? What does that effect have to do with it, and how does that work? You should be able to get most of what you need from the links in this PDF, but if not, then you can do some research on your own as well. As you probably know, there was a big world summit this past week discussing dealing with climate change and making plans, and it was, I don't know, maybe moderately successful, slightly successful, something like that. But we still have a long way to go, and it's still a big danger. So we're going to be talking about this a bit more. I want to give you a chance to complete this, and then next week we'll look at some of the results. So for the second page, there's a whole list of different processes that involve greenhouse gases. So once you've identified them and you know what types of things are greenhouse gases and why, then you can move on to this, which asks you to, for each of these, identify the greenhouse gas involved. So these are sentences that describe a chemical process. Then you want to label the activity as either a source or a sink for the greenhouse gas. So a source means it produces that gas, and the sink means it absorbs it or gets rid of it or consumes it. So in some cases, it may be both. It may be a source for one gas and a sink for a different gas. So it's not always just one or the other. But in any case, when there is a when there is a greenhouse gas involved here, you want to say what it is, and then is it produced by the reaction or is it consumed in the reaction? And we're going to go through an example also here. For each source, is this something that is anthropogenic? So this is something that we do as humans, or is this something that just naturally happens in the world? And then finally, you're going to write a balanced chemical equation to represent the process. So we'll do the first one as an example here. During respiration by plants and animals, a carbohydrate, such as glucose, C6H12O6, reacts with oxygen to produce water and carbon dioxide. Glucose, we're going to say glucose reacts with oxygen to produce water and carbon dioxide. So that's our, that's the sentence that describes the reaction, and we want to make a chemical equation based on that. So we're looking for words like reacts with, which generally tells us it's on the left side, the reactant side of the equation, and then produces or makes or results in, something like that, which generally tells us about the product. Now, some of these are not written necessarily in that exact order. So for example, let's look at the very last one. In order, I don't know if you can see it here. If I can move it over a bit. All right. In order to produce calcium oxide for use in cement production, calcium carbonate is heated. So in this case, the producing is given first. So our product is calcium oxide, and the reactant is the thing that's something's happening to it and is heated. You'll notice in this one that it doesn't say it reacts with anything because it's not reacting with anything. It's the only reactant is calcium carbonate for this example. That's the only thing that is a reactant, and then there are two products, calcium oxide and carbon dioxide. Let's go back to our example for the first one, and we'll do the whole thing. So, during respiration by plants and animals, blah, blah, blah. Okay. Identify the greenhouse gas involved. Well, in this case, there are two. Water and carbon dioxide are both greenhouse gases. Glucose is not a gas, and oxygen is not a greenhouse gas for reasons that hopefully you will know from working through the first page of this activity. And is it a source or a sink? Well, the water and the carbon dioxide, those are the greenhouse gases in this equation. Those are produced. So this would be a source. It's producing those gases. Is it human-made or natural? Well, I would say in this case it's natural. I mean, humans are animals also, but it's just saying in general when there's respiration, carbohydrates produce this. So this is a natural process. And then finally, we're going to write a balanced chemical equation to represent that. So let me get some paper here. All right, so we've got glucose, which is C6H12O6, reacts with oxygen, O2, to produce carbon dioxide and water. Okay. And now we have to balance equations. There was a balancing equation activity last week, so hopefully you get some practice with that. We're going to count up the atoms on each side. So this side has 6 carbons, 12 hydrogens, and 8 oxygens. This side has 1 carbon, 2 hydrogens, and 3 oxygens. So we have to add coefficients to the front here to multiply those, and so there's enough of each so that they're balanced on both sides. So 6 on the left, 1 on the right, so we're going to put a 6 here, and that changes this to 6 carbons on the right, then 13 oxygens. So now we've got 12 hydrogens on the left, 2 on the right, so we want to put a 6 here so that we have 12 total on the right as well. That's also going to change the amount of oxygen. So that's, let's see, 12 plus 6 is 18. So then we need 18 oxygens on the right total. So we've already got 6, and so that means we need 12 more from this. Now we should have 18 oxygens, and now we have the same atoms on both sides. So there's our balanced equation. That's how that works. So that's how you would do the this part of the activity. So go through all those equations and answer the questions, balance the equations, be good to go. Other than that, you've got the biodiesel project to complete. We went through, I believe, all of the calculations last week. If there are any that are still giving you trouble, please let me know. Oh, that reminds me, there is one mistake on there. So let's take a look at that. So in the final analysis of biodiesel here, number 2, we went through calculating the theoretical mass of biodiesel. That's what we did last week. And you can put in your numbers and follow along with what we did. But we did not do the other parts of this question, the theoretical mass of glycerol and the mass of methanol. You can skip those. Skip those, just do the theoretical mass of biodiesel. And you don't need to do the other ones for this project. Everything else, there's a lot of kind of research stuff to do. We did the heat of combustion together. We did the percent recovery together. And the rest of it is kind of for you to answer on your own. Please keep in mind, number one should kind of be the biggest question here. So you should be doing the most to answer number 1, because that's supposed to take in all of the results, all of the data that you saw. How do you prove that you did indeed produce biodiesel? So you have to kind of look at everything to figure that out. The GCMS data, the results of things like methanol test and wash test, as well as whatever I'm blanking on and forgetting about right now, density, things like that. So everything that you measured should contribute to your answer to this question of did you produce it or not? All right. As usual, let me know if you have questions, and I will be back on next week to talk more about this on Thursday. Hopefully it'll work okay. I'll plan to go back at the regular time at 9:30 a.m. We'll see you then. Bye.